Okay, we are going to start off on geometric sequences. Now, why do they call it geometric? I'm not exactly sure the idea of geometric, but geometric sequences, what am I even talking about sometimes? Let's just get into it. Our goal is to be able to find and recognize geometric sequences and find and indicate terms of geometric sequences as well as identify the geometric mean. Okay? Those are our goals. And let's just start with the first one so I stop rambling so much. What is a geometric sequence? Well, here's how I define it. In a geometric sequence, each term, okay? Each term, so let's say I have, 1, 2. These are terms. Each term is found by multiplying the previous term by a constant, otherwise known as a common ratio. Multiplying each term by a common ratio. That's what a geometric sequence is. So for example, let's say here I got this geometric sequence right here. Let's start with 1. And I'm going to multiply each term by 2 to get the next one. So 1 times 2 is 2. And then 2 times 2 is 4. And 4 times 2 is 8. And 8 times 2 is 16. And 16 times 2 is 32. So forth and so on. And so this creates what's called a geometric sequence. The geometric is because we're multiplying by a constant thing called the common ratio each time. And that's what makes it a geometric sequence. Now, there are two forms of defining a geometric sequence. The first form is the recursive form right here. You've seen this in 11.1. It was maybe a little bit different, but the recursive formula for a geometric sequence is given as this: T sub n, you can think of this as your next, is equal to the common ratio, r, multiplied by your now. So you take your now, say 1, and multiply it by the common ratio, say 2, you will get your next, which is 2 in this situation. Okay? But here's the thing, recursive formulas need a starting point. And in this situation it's not listed here, so we need a T sub 1, our starting point, our start. You can think of this as your start. Start is equal to T sub 1. In this situation, what was our start when we looked at this example up here? Well, our start was 1, so our T sub 1 was 1. So you need that part of the recursive formula as well. The other type of formula you can use is your explicit formula. What's nice about the explicit formula that's given here for a geometric sequence is that you can jump to any term in the sequence just by knowing 3 parts. By knowing the common ratio, the term you want to find, and the start, T sub 1. Okay, so like the examples that I gave up here, right here, okay, we could find out what this is, this 32 is, without finding these others using the explicit formula, where you need to use the recursive formula to get to 32. You'd have to find each one beforehand. You would have to find the 16 and this 8 and this 4 and this 2 all before you could find that 32 using the recursive formula. Explicit formula means you can just jump ahead to that term. So this is how you would do it on there. We have T sub n. Well, we want to find the 32nd term, or this term, and we don't know what it's going to be, but we know it's the 1, 2, 3, 4, 5, 6th term. So we want to find T sub 6. Well, that's equal to T sub 1, which we know is 1, times r, which we know is our common ratio. In this situation, our common ratio is 2 because we're multiplying by 2 each time. To the n is the term we want to find, which is still 6, n minus 1, so 6 minus 1. Well, this is equal to 1 times 2 to the 5th power. 2 to the 5th power is equal to 1 times 32, which is just equal to 32. So see how we can kind of jump ahead using an explicit formula. So those are 2 types of formulas we can use to define geometric sequences. In this next part, let's see what we're doing in this next part. We are going to use these 2 types of forms, recursively and explicitly, to find the 5th term of a sequence that has a starting value of 8 and a common ratio of 3.